next problem is called longest consecutive sequence. We are given an unsorted array of integer nums, and we have to return the length of the longest consecutive element sequence. We have to write an algorithm that runs in linear time. So let's just go through an example. Here we have, as you can see, we have 1, 2, 3, and 4, which are, because this is unsorted as given by the problem statement. When sorted, it will be like this: 1, 2, 3, 4, and then we will have 100 and 200, but this is not consecutive because, for example, if we had 101, that these two will form a subarray sequence of length 2. But because we don't have 101, this is just a sequence of length 1, just as we have for the element 200. But this sequence here is of length 4. So our maximum sequence, maximum consecutive sequence is of length 4. So we return that as the result. In the second example, you can see that we have just unsorted sequence ranging from 0 up to 8. So we have nine elements in total. The easy way to get it is basically just this start and this is the end. So to get the sequence, we just do end minus start plus 1 because it's inclusive. So we will have 8 minus 0 plus 1, which is equal to 9. So we'll just return 9. Now, if you go through an example, we will solve this problem by iterating over the array in linear time fashion. So we have to use some auxiliary data. We have to use some helper data structure. In our case, we will use a hash map, and for each of the elements, we will have a mapping between the element and the total length, the maximum length so far up until this point. So for a certain element, let's say 5 can be an element that we found inside the array, and the whole length of the chain of the sequence that this element is forming with other elements, it's currently, for example, 3. So for example, we had seen 3, 4, 5, something like that. Now, while reiterating over the array for each of the elements, we will check if we have the element before. So for example, in our input array, we have number 4. So we are checking for 4 minus 1 is equal to 3. We are checking if in our hash map, do we have our left boundary? We can call it left boundary. So number before the number that we are observing right now. And the same goes for our right boundary. So we will do a number that's after it. So in this case, we are looking for 5. Because we don't have anything in the hash map, the total length for the current element is scoring with all the other elements that we have found in the hash map is basically left chain, right chain, and plus 1 for the element that we are observing. So for this case, we will only have total length as 1. Next, we go to the next element, which is 3, and we are checking. So for the number 2, we don't have it inside the hash map. So we are checking for number 4, and we have it. So we can form a sequence containing only numbers 3 and 4. So our total sequence will be the one for the current element. For left, we don't have anything, so it's 0, and for the right, we have the value 1 inside the hash map. So the total length will be 2, and we will insert that in our hash map. So for this key, we will have total length of 2. Now for the next element, we have 2, and the previous element for the element 2 would be 1, and we don't have it in our hash map. So we are searching for its next element, which is 3. In this case, we have 3, and the total length will be, so we are counting 1 for the current element 2. Then for the left, we don't have the 1 inside the hash map, so it's 0. And for the right, we have number 3 for the key, and the value is 2. So the total length for the element 2 will be equal to 3. Now, that sequence is basically 2, 3, and 4. So it's a valid sequence, and we have successfully recorded it. And for each number, we are tracking the max length so far. So we have a global variable called max length, and we are checking basically if for the current element, we have a length, a subarray, and that contains this element that forms a subarray that has a length larger than the currently largest recorded length. Now we proceed with all the other numbers. We are at number 7, and for 7 we don't have the number 6 and we don't have number 8, so we are just recording 7 as a single element sequence. Now for the number 8, we have the left one. We have the 7, so it will be 1 plus 1 plus 0 is equal to 2. So 8 will map to 2. Now for number 9, we don't have the next element. We don't have 10, but we have 9 minus 1 is equal to 8. So we find it in our hash map, which is equal to 2. So we will have 1 plus 2 plus 0, which is equal to 3. So 9 will map to 3, and that's the sequence actually 7, 8, 9. Now we will have the following sequences. We'll have 7, 8, and 9. So in this case, and we are also, each time that we have a valid sequence, so for example, for number 2, we found number 2 as the third element, and we update its length as 3. But we will also update the length of its furthest boundary. So in this case, if the furthest boundary, so for example, -1 here, we will update also the total length for this element. In this case, in the right side, we have number 4. So we will update the length of 4 to be equal to the same length that we now got with the element 2. So in this case, it will be 4 will be mapping to 3. We are using that because once we find an element a correct sequence, so that's merging the two chains, we want both boundaries to have the total length of the chain. So we can easily calculate the total chain after the merging. So in this case, we will have 6 and 5. Now 6 will come here, and we will update the length at 9, and we will also put 6 to be 4 inside our hash map. Now for the element 5, we will have both 5 minus 1 is equal to 4 and 5 plus 1 which is equal to 6. Now the sequences will be 2, 3, 4, 5, and the 5 will be just merging to this sequence too. So we have to update the whole boundary. So we will basically update the number 2, which is the leftmost boundary, to contain the whole length of 8 elements. And we will also update the rightmost element, which is 9, to contain the length of the subarray that we have found, which is in this case again 8. Now, once we find an element, we don't want to recalculate its length once we find it again inside the array. So if we had an additional 5 here, we wouldn't want to again calculate the boundaries because there's no reason. In this case, we would be just calculating the whole length twice because we will be getting the left, which has been already updated by the first 5 because it's the leftmost boundary, and we will also getting the right. So basically, we will be updating the left and right boundary 2 times, and the total length will be actually 2 times of the real value. So we will just be doing the calculation once. We will be, if the element is already inside the map, we already did the calculation, so we can skip it. So we'll start by declaring the hash map that will map the current element with the maximum length of the chain or sequence that is forming with other elements. Next, we will set the max sequence length as a global variable, and we will track if that variable changes for each of the elements that we traverse over, and we will return it as the final result of our function. Now we will traverse through all the elements inside the input array. For each element, we will first check if we have already calculated the boundaries and the maximum length that element is for with other elements by just checking if the element already exists inside the hash map. If it does, we just basically skip over it and proceed to the next element. Next, we will check the left boundary. What's the chain that we get by including the previous number from our current number. So if we have 5, we will be checking what's the total length the number 4 is forming with other elements. The same goes for the next element of our current element. In this case, if we have 5, we will be checking what's the total length of a sequence that 6 is forming with other elements. And also, of course, the default will be 0 if you don't find that element inside our hash map. Now, the total length of the new chain that we are getting by including our current element, we might be merging two chains. It's +1 because we are including our current element, and this total length of the chain that we got from the left side and from the right side. Now we want to update the leftmost boundary, and to get that, if we found our left element, we basically, from our current element, we just decrement the total length of the previous chain that the left was forming it to get the first number in that chain. And we set the total length that we calculated before to that leftmost boundary. We do the same for the right by just incrementing the current element by total length of the chain that we found by checking the next element from our element. So in our case, for example, if we had 5, we will be checking the element 6. And then we will just place our current element and the corresponding length that we have already calculated inside our hash map, and check if we can update our maximum sequence length by checking if the length that we have found for the current element is larger than the best so far length that we have found. If it is, we will just set it. If it's not, we will just keep it as it is. At the end, we will just return that max sequence length as the result of our function. And because we are only traversing the array, we only have a linear time complexity as per the problem statement. And for the space complexity, we only have the hash map, and each element will be placed inside the hash map. So basically, we have a linear space complexity proportional to the length of the input array.